We'll discuss and explore the data flow lifecycle of Redux, and we'll also illustrate how to utilize data flow with Redux-based applications. Now, the Redux architecture is based on unidirectional data flow. It basically means that all the data in an application will follow a similar lifecycle pattern. When the data follows a similar lifecycle pattern, they become more predictable, easier to understand, and we don't need to follow multiple data flow cycles. Now, unidirectional data flow provides another benefit, ensuring that data is normalized, so we don't end up with multiple independent copies of the same data, with the copies not being aware of each other. And since Redux follows unidirectional data flow mechanism, debugging and testing is simplified as well. Now let's explore how the unidirectional data flow is implemented using the sample illustration figure. Let's assume that we've taken an action. The action is passed on to the reducer, which will manipulate the state and return a new state. The new state is stored in the Redux store, which in turn notifies the change to the view component, which is the virtual DOM. Finally, after the difference between the virtual DOM and the physical DOM has been identified, the HTML content will be rendered to the user. So using this particular unidirectional data flow, any action which takes place on the current user interface will pass through the same life cycle. The current state and the new state will be compared and the content will finally be rendered. Now let's explore the Redux data flow steps that we will be implementing to manage the data flow life cycles. We'll begin by calling the dispatch method and pass action to the method. The action is an object which specifies the event. For example, there can be an action which is derived from the user's input. After we've dispatched the action, we can store the dispatch data. And in order to store the dispatch data, we'll call the store method and pass two arguments to the reducer, the current state tree and the action itself. Now, if we have a single reducer, it will take that particular output and give a single state tree. But if we have multiple reducers, the root reducer will combine the output of the multiple reducer into a single state tree. And finally, the Redux store will save the complete state tree, which is returned by the root reducer. There are multiple subscribers who will subscribe to that particular store. And soon as Redux saves the complete state tree, the method store.subscribe will be invoked. We'll pass an argument of type listener to the method store.subscribe, which actually listens to the changes in the state. After the listener is notified about the state changes, we'll call the method getState, and this method will return the current state. Then we'll use the state that we retrieved as an output of the getState to update the state of component by calling the method setState. The method setState will reflect the new state of component, and it will be rendered to the user. Now, in order to manipulate or work with states, Redux provides certain important APIs. The first API is to create the Redux store, and we'll be using createStore method with two different arguments, the reducer and initial state. If there are multiple reducers, we can use the combine reducer method or function to combine them into a single reducer. We can use the compose function to compose the state of the object, and the function will be called from left to right. Now, if we're using a middleware, we'll use this method, apply middleware, to manipulate and integrate the states. And finally, we can bind several action creators to the dispatch function by using the method bind action creators. So using these APIs, we'll be able to manipulate the state and utilize the state in order to prepare a new state, which can be rendered with the component. Now let's explore how middleware can be used in Redux. By default, Redux supports synchronous data flow, but that may not always be the necessity. Sometimes we need to async flow as well, and such async flow in Redux is provided by middleware. Now, in order to facilitate async flows in Redux, there are various middleware, of which the two most prominent ones are Redux Thunk and Redux Promise. A typical middleware implementation in Redux is illustrated in this sample figure. One async flow is typically equal to two sync flow, And this particular manipulation will be handled by middleware as illustrated in the sample figure, where the components include the backend, Redux, and UI. So if we want to manipulate the data flow lifecycle in Redux, we'll be doing so using middleware.